All right, guys, so we are going to do the section 6.1, and in this section 6.1, problem number 1 is decide whether each function is a one-to-one function. So what I want to do is also try to review a little bit for your final, and one of the things I want to review is to graph a function. We have a linear function. Why do we have a linear function? Because we having a function looking like f of x equal mx plus b, with the slope m equal -3 and b equal 5. When you have the slope, you can also define the y-intercept, which is the point of intersection between your y-axis in your line, and it is when x equals 0, what is the value of f of 0, and the value of f of 0 is going to be equal to 5. So if you want to graph that function, you will graph a Cartesian system coordinate with the y-axis and x-axis, where y equal f of x, and you are going to plot your y-intercept, which is 1, 2, 3, 4, 5. This is the y-intercept right here, 0, 5. And from this y-intercept, because we have a slope, and we need to think in terms of rise over run. When it's going up, it will be because the numerator is positive, or when it's going down, it will be because the numerator is negative, going to the right, going to the left. And so we have a slope equal -3, meaning that it's going to be -3 over 1. So I need to go down to 3 units and 1 to the right of 1 unit from the y-intercept. That allow me, so I need to go down 1, 2, 3, and 1 unit, and that is going to be my line. Now, let's go back to the problem, which is defining if it is a one-to-one function or not. So what's the definition of a one-to-one function? Well, the definition of a one-to-one function, as we said, was that if we have two numbers, a different than b, that implies that the value of that function when x is substituted by a will be different than the value of my function when x will be substituted by b. So basically, f of a will be different than f of b. And so what I can do is I can choose two numbers, and I can literally choose that value of a right here and that value of b right there. And I can clearly look at f of b, and right there, f of a, I can clearly see that f of a is different than f of b. So yes, this function for the problem number 1 is a one-to-one function. Now, let's problem number 8. On the problem number 8, we have the function f of x equal the cubic root of x. So you are supposed to know the expression of the cubic root. As you know that square root will be something like this, and cubic root will end up to have also this part. And I can again see that for two values of a different than b, end up to have f of b different than f of a on the y and the x-axis. So number 8, it's also yes, it is a one-to-one function. Now, next problem is supposed to be problem number 28. So what do we have in this problem number 28? For f to be a one-to-one function, 28, for f to be a one-to-one function, so basically f is a one-to-one function if when you have a different than b, f of a will be also different than f of b. All right, now problem number, I forgot the problem number, 37. On this problem number 37, what do we have? Use the definition. Oops, I'm going to get rid of that. Use the definition. So we have f of x equal 3x minus 7, and we have g of x equal x plus 7 divided by 3. If these functions are inverse to each other, I am going to calculate f of g of x, and it's supposed to be equal to f of g of x, and at the end my answer should be x. If I don't have equal x, that means my function is not a one-to-one function. So to do that, I am going to take my function f right here. So I'm going to take my function f. So f of g of x is going to be, I'm going to take my function 3x minus 7, and I am going to substitute this x right here by g. Okay, so we have right there g of x. This is g of x, and I am going to substitute it by x plus 7 over 3. All right, so that said, what I'm going to do is I'm going to divide out the 3. We got x plus 7 minus 7, and we end up to have equal x. Because we are checking that f of g of x equal x, we can say that these two functions are inverse to each other. F of x and g of x are inverse of each other. All right, problem number 42. So what do we have in this problem number 42? We have the function f of x equal negative x to the 7, and we have g of x negative the 7th root of x. And the question is showing that f of x and g of x are inverse of each other or not. So for that, I'm going to calculate f of g of x. And by the way, I could also calculate g of f of x. At the end of the day, for the first one, I'm supposed to calculate f of g of x by substituting inside f all the x by g of x, and I'm supposed to find x if they are inverse of each other. Or it could be the same thing with g of f of x. I will substitute inside of g all the x by f of x, and I'm supposed to find x. If I find that, they will be inverse. So I'm going to calculate the first one, f of g of x. So for that, I'm going to take negative x to the 7, and I am going to substitute this by g of x. And actually, I'm going to write my g of x in green right here. So I am getting rid of the x, and I am substituting by g of x being equal to negative the 7th root of x. I end up to have a negative 1, and this negative 1 comes from the negative in front of my 7th root to the 7 multiply by the 7th root of x to the 7. Negative 1 to the 7, it's still negative 1, and negative by negative give me a plus. So this is going to be ending to be equal to plus 1. Multiplied by the 7th root of x to the 7 is going to be x. At the end of the day, I end up to find that f of g of x equal x. So yes, f and g of x are inverse. All right, in this problem number 44, determine whether each function is a one-to-one, and if it is a one-to-one, what is the inverse? So first of all, when I look at the problem number 44, I can see that the set of solution 5, 12, 10, 22, 15, 32, 20, 42 present for different value of x, we have different value of f. And so that allows me to say this is a one-to-one function. And if it is a one-to-one function, that means I have an inverse. And the inverse would be that all the x becomes y and all the y becomes x. So we ended up to switch the value. And what was x equal 5 is now y equal 5. What was y equal 12 becomes x equal 12. And so this is the set of solution for g, for the inverse of g. For the problem 46, it's another thing, because when we look at the function, it's not a one-to-one function. And that's very simple. You will notice for x equals 0 right here and x equal 2, we have exactly the same value of f, which is 10. And that's not possible, because you are supposed to know that when you have a different than b, f of a has to be different than b in order for you to say that we have a one-to-one function, okay? One-to-one. And that is not the case. So in this problem, you cannot find the inverse of f. All right, in this problem number 52, an everyday activity is described, keeping in mind that the inverse, that an inverse operation undoes what an operation does. So if in the problem number 52 you are climbing the stairs, okay, the inverse operation of that will be descending the stairs. And so the inverse would be descending the stairs. Problem number 62. And if I'm correct, that's the problem you have to do. So in this problem number 62, we have y equal 4 over x. And the idea is to find, for each function that is a one-to-one, find the expression of the inverse of the function. So we are dealing with a one-to-one function, and if you want to find the inverse, the only thing that you need to do is substitute x by y and y by x. Therefore, I end up to have something that would be like x equal 4 over y. And then you are going to re-express y by itself. In order to do that, you will have to multiply by y both sides in order to be able to divide out the y, but you will have also to divide by x both sides in order for you to get rid of the x and have your new y by itself. And in that case, we end up to have, and this y will correspond to the inverse of your function f of x. And in that case, you end up to have an inverse function equal to also 4 over x. It's not always the case, but in that case, that's what we have. All right, now problem number 72. In this problem number 72, the given function is a one-to-one, find the inverse. So we have a problem, and this problem gives us f of x equal to square root of x minus 8. And they are telling you that there is a condition x will be greater or equal than 8. So if I want to find, so basically what we have is y equals square root of x minus 8. If I want to find the inverse, I will substitute y by x and x by y. Now, I need also to be able to isolate my y. Therefore, I will have to square my x equal the square root of y minus 8. And obviously, it's going to be x squared equal y minus 8. Now I can isolate my y, which will be expressing the inverse of my function, by adding 8 both sides. And now I can literally express y equal x squared plus 8. But I need to give a condition that will be x greater than equal than 0. And that will be the expression of my inverse function, f minus 1 of x, equal y equal x squared plus 8. All right, guys, I'm going to make a second part for the video. Thank you very much, and talk to you soon.